Next problem, find the root of the equation x to the power of x minus 10 equal to 0 using secant and regular falsi method. Correct to 3 decimal places. This is 3 decimal places, not accuracy. Remember this point. Solution. What is our function? Given function is f of x equal to x to the power of 4 minus x minus 10. Okay, first we have to locate the interval. For this, let us substitute x equal to 0. Need not be x equal to 0. You can take x equal to minus 1, minus 2, 1 by 2, 1 by 3, anything. Let me start with x equal to 0. Then this is negative 10, so negative value. Put f equal to 1. Then this is 1 minus 1 minus 10. This is also minus 10 negative. Let us take f2, x equal to 2, that is f2. This is 16 minus 2 minus 10, that is 4 positive, right? Since f of 1 less than 0, f of 2 greater than 0, the root lies between 1 comma 2. Okay, therefore what is x naught value? 1, and x1 value 2. So first one, secant method. What is the formula of secant method? The recursive formula of secant method is or iterative formula. The recursive formula of secant method is, what is that? Xk plus 1 is equal to xk minus xk minus 1 by fk minus 1 multiplied by fk. Okay, therefore at k equals to 1, this is for k equals to 1, 2 and so on. For k equals to 1, what is x2 equal to? x1 minus x naught by f1 minus f0 into f1. Okay, and remember this is here x0 is 1, x1 is 2, and what is f1 value? F1 means what? F of x1. F of x1 means what? F of 2, that value is 4. And f0 means what? F of x0, that is f of 1. What is that value? Minus 10. Now substituting these values, x2 will be, substituting these in formula, x2 will be what? x1 value is 1 minus x1 value 2 minus x1 minus x0 by f1 minus f0, that is 4 minus of minus 10 into 4. So this is 2 minus, this is 4 by 14. So result is 1.7143. Next, now what is x3 formula? x3 formula, x2 minus x1 by f2 minus f1 entire multiplied by f2. And after getting this one, find f of x2. This is nothing but f2 value. Find this value, something, use calculator to find this value and substitute all these values here. You will get x3 as 1.8385. Similarly, x4 equal to x3 minus x2 by f3 minus f2 multiplied by f3. And after substituting this, after this, calculate f3, means f of x3 value. You calculate here this value and substitute in x4, then x4 becomes 1.8578, 1.8578, and x5 value, x4 minus x3 by f4 minus f3 multiplied by f4. This value is 1.8556. This is lastly x6 equal to x5 minus x4 by f5 minus f4 multiplied by f5. This value is 1.8556. Therefore, the root correct to 3 decimal places. Correct to 3 decimal places is 1.8556. This is 8. So this is equal to 1.1 can write 856. We have stopped this one up to this one. Okay, 3 decimal accuracy we are getting. Now using Regula Falsi method. Secant method is over. Now using Regula Falsi method. Regula Falsi method. What is the formula? The recursive formula of RFM, Regula Falsi method, is same formula: xk plus 1 equal to xk minus xk minus 1 by fk minus 1 multiplied by fk, k equal to 1, 2 and so on, with condition. What is the condition? Extra condition other than in RFM, with the condition fk into fk minus 1. Find f of xk and f of xk minus 1, and the product must be less than. That means fk and fk minus 1 are having opposite signs. Okay, and already we know that what is x naught equal to 1 and what is x1 equal to 2, and what is f naught value minus 10 and what is f2 value 4. Okay, all these we are having. Therefore, what is now x2 equal to x1 minus x naught by f1 minus f naught multiplied by f1. That is equal to the root. After substituting entire values, we are getting 1.7143. I will write now f of x2 value, that is f of 1.7143 value. Substitute in the equation: 7143 whole power 4, 1.7143 minus 4. This entire value is minus 3.0776, negative. Okay, now since what is f of 1.7143 is negative, which is positive in the first interval, f2 is positive, f of 2 is positive, the next root x3 belongs to what interval? 1.7143 comma 2. Okay, and treat this as, now this is what, this is like x3 value depends on x1 x2, x3 value depends on x1 x2, and is treat this interval as x1 comma x2, and is x3 equal to x2 minus x1 by f2 minus f1 multiplied by f2. Now substitute all the values. We have, this is f2 value, f2 equal to this one. Okay, so after substitute, you know what is x2 is 2, x1 is what, 1.7143, and f2 is here, it is the value is here. f1 value is what, Now the change is here. Okay, let me write. F1 means here what? F1 means what? Yeah, exactly. There is some change here. This is not F2. Okay. Here, let me write clearly. Here F1 means what? F of 1.7143. This value is minus 3.0776. And F2 value is what? F of 2. F of 2 value already we have 4. So substituting all these values, I am getting x3 as 1.8385. 1.8385. Now let me calculate f of x3. That is equal to f of 1.8385 is equals to 1.8385 power 4 minus 1.8385 minus 4 equal to this f of x3 value minus 0.4135, and this value is negative. This value is negative. Now since f of 1.8385 less than 0, and in the previous interval which is positive, f of 2 is positive, and f of 2 is positive, the next root, what is that? x4 belongs to what interval? 1.8385 comma 2. Now assume this interval as, what is this? x4 belongs to what? x2 x3. Recurrent x1 x2, next x2 x3. And what is the formula? And here what is f of x2 means what? This is f2. F2 means what? F of 1.8385. What is this value? Minus 4.4135. And f of x3 value is nothing but f3. What is f of x3? 2. This is 4. I think you got it. Always the interval is changing, and the corresponding f values also change. So what is x4 is now x4 formula x3 minus x2 by f3 minus f2 divided by multiplied by f3, and x4 value is 1.8536. Now f of x4, that is f4. Okay, f of x4 means this is f of 1.8536 value. This is minus 0.0487, negative. Now since f of 1.8536 is negative, and which is positive in the previous interval 2 is greater than 0, the next root x5 belongs to 1.8536 comma 2. So what is this interval? Now we have to take x5 means here you will get x4, and here you will get x3 comma x4. Therefore what is f3 becomes? F of x3 nothing but f of 1.8536. already we have this value 0.0487, and f4 value is f of 2. Directly this is 4. Therefore what is the next? x5 equal to x4 minus x3 by f4 minus f3 multiplied by f4, and this x5 value is 1.8554. okay, and f of x5 nothing but f5. This is equal to f of 1.8554. this value is minus 0.0045, negative. Now since f of 1.8554 is negative, and which is positive in the previous, f of 2 is positive, the next root, what is that root? x6 belongs to what interval? 1.8554 comma 2, and is, apply the formula, x6 equal to what is that? x5 minus x4 by f5 minus f4 multiplied by f5. And here I am writing here what is x5? You know, x5 is what? 1.8554, right? Sorry, x5 is here. This is what? Compare this interval. This interval is what now? x5, this is x4, x5 x4. Therefore x4 equal to same thing. So f4 is nothing but what? F of 1.8554, that is equal to minus 0.0045 value, and f5 value is what? F of 2, that value is 4. So what is this value after substituting everything? This x6 value is 1.8556. Now see, 1 point after decimal point, 3 decimal places are same, right? Therefore the root correct to 3 decimal places, is 1.8556, approximately 1.856. These are the two problems based on secant method and Regula Falsi method. And the next iterative method based on first degree equation is Newton Raphson method. Newton Raphson method. Okay. Now here consider the first degree equation. First degree equation, f of x equal to a naught x plus a1 equals to 0. Therefore a naught x plus a1 equals to 0, take this as 1, implies x equal to minus a1 by a naught. This is equation 2. Okay, to find the unknown constants, a naught and a1, consider the conditions. The first one is f of xk at x equal to xk, f of xk equal to a naught xk plus a1 equals to 0. Okay, that is fk equal to a naught. Let us remove this. That is fk equal to a naught xk plus a1. Just consider the function f of x not equal to 0. Just take the function f of x. Now f dash x, what is f dash x equal to? Just a naught. Therefore f dash of xk equal to what? A naught. That is a naught equal to simply the notation f dash k. This is 3 and this is 4. Put a naught value in 3. Then what is 3 becomes? This is fk equal to a naught is what? Fk dash xk plus a1. This implies what is a1 becomes? Fk minus fk dash into xk. Then substitute a naught value and a1 value. Substitute a naught and a1 in 2. Therefore 2 implies what? X equal to This is x only. This is x only. X equal to minus a1. What is a1? Fk minus fk dash xk by a naught fk dash. So this minus, if I include this minus here, then this becomes xk minus fk by fk dash, k minus fk dash. Therefore, now replace x by xk plus 1, then xk plus 1 equal to xk minus fk by f dash k. This is k equals to 1, 2 and so on. Sorry, 0, 1, 2. 0, 1, 2 and so on. This formula is called Newton Raphson method. Newton Raphson method. There is another way to derive Newton Raphson method. See, alternate way or another way to derive Newton Raphson method. Let x naught be the initial approximate root. X naught be the initial approximate root of f of x equal to 0. Okay. Let x1 be the exact root. What is x1? Exact root of f of x equal to 0. Therefore, what we have, since it is exact root, f of x1 equal to what? 0. Okay. x1 be the exact root of the f of x equal 0, such that what is x1 is nothing but x0 plus h. x1 is taken as x0 plus x0 is approximate solution. For this x0, if I add some error value, then it becomes exact. Approximate plus error is equal to exact. So x1 is exact. Since x1 is exact, f of x1 equals to 0. Therefore, now let us substitute x1 value x0 plus h equals to 0. Now f of x0 plus h equal to 0, what is the Taylor series expansion? F of x0 plus h into f dash x0 plus h square by 2 factorial f double dash x0 plus and so on equals to 0 using Taylor series. Using Taylor series of f of x0 plus h. Okay. Then neglect the higher derivatives. F of x0 plus h into f dash x0 is approximately 0. What is the thing here? Why approximate symbol we have used? Because we are neglecting higher degree terms. Higher degree terms. So it is not exactly equals to 0. It is approximately equals to 0. From this, what I am getting, h equals to, not exactly h equals to minus f of x0 by f dash x0. Done. Okay, and remember what is x1 solution? This one, h equal to, then therefore what is x1 becomes x0 plus h. But what is this h? It is approximate only. Therefore this approximates to x0. What is h value? F of x0 by f dash x0. Okay, therefore what is x1 formula? x0 minus f0 by f dash naught. This is the first approximate root. See, in this expression, if I put this k equal to 0, what you will get here? x1 equal to x0 minus f0 by f dash x0. Right? This is the first approximate root. Similarly, now let x2 be the exact root. x2 be the exact root of f of x equal to 0, where what is exact means? Previous approximate root plus some error. Okay, therefore f of x2 equals to what? 0. That implies what is x2? x1 plus h equals to 0. Let me again apply Taylor series formula. F of x1 plus h into f dash of x1 plus h square by factorial to f double dash x1 and so on equals to 0. Now neglect the second and higher order terms. So f dash x1 equals to approximately 0. From this, what I am getting, h equal to minus f of x1 by f dash of x1. Therefore, what is this? X2 becomes, therefore x2 equal to x1 plus h becomes, what is this h now? Approximate. This is approximates to x1 minus f of x1 by f dash of x1. Okay, therefore what is x2 is now formula, x2 equals to x1 minus, this is not exact now because we are neglecting some terms, is the next root. Next exact root becomes what now? Approximate root. So in general, if we proceed in this manner, what I am getting, xn plus 1 equal to xn minus f of xn by f dash of xn is the NRM formula, is the Newton Raphson method iterative formula. Newton Raphson method iterative formula. Okay, is that clear? I think the derivation is clear. Previous one is simple using first degree equation, and the next alternate way is by using Taylor series expansion. Now see the geometrical interpretation, geometrical representation of Newton Raphson method. Okay, what is the thing here? Consider the curve y equal to f of x corresponding to the equation f of x equal to 0. Okay, now this is the curve. Let me take x-axis and this is y-axis. Let me consider this curve like this, and this is my point x0 and this is my point x1. Okay, take this point x0. I think no need of this x1 also. Okay, x1 point, let me draw clearly. See, this is the graph, this is x-axis and this is y-axis, and let me take the shape of the curve like this, for example, and let me consider the initial approximation x0, at this point. Let x0 be the initial approximation, draw a tangent at x0 which cuts x-axis at the next root x1, If I at this point, if I draw a tangent to the curve, this is x1, this is the next approximate root. Okay, find f of x1, that means this is f of x1 means what? This is the point on the curve, this is f of x1. Now at this point again draw a tangent to the curve, this is the next approximate root x2, this is exact root xi. Okay, find f of x1. Now at the point draw a tangent at this is x0 comma f0, draw a tangent at x1 comma f1 which cuts x-axis at the next root x2. Okay, proceeding in this manner, we get the approximate roots closer to exact root. closer to exact root. This is geometrical representation of Newton Raphson method. What we are taking, first consider the curve. This is the curve, okay, and take the initial approximation x naught and find f of x naught. This is x naught comma f of x naught. Draw the tangent at this one which cuts the x-axis at the next approximate root x1, and find f of x1 on the curve. At that f of point, draw the tangent which cuts x2 and find f of x2. F of x2 at this point, this is f of 2. At this point, draw a tangent. Like that way, if we go on drawing the tangents at the approximate roots, the approximate root tends to exact root. This is geometrical representation of Newton Raphson method.